Hello everyone, and then welcome to another tutorial video. So in this video we'll be treating what Jacobian. Okay, so in case you know anything about Jacobian is simply about matrices and determinants. Okay, so just get this concept, get this at the back of your head, and then you'll be good to go. Okay, Jacobian is all about matrices and what determinants. Okay, so it could be a 2 by 2 matrix, finding the determinant of a 2 by 2 matrix, or what finding the determinant of what a 3 by 3 matrix. Now, in case you are new to this channel or your first time watching our video, I would urge you to subscribe to the channel so that you don't miss out on future videos, because on this channel we provide smart ways of learning specific topics, especially difficult topics. Okay, so without further much, let's just dive right into this video. Right, so for Jacobian, as I already stated, it's all about what finding the determinants of matrices. Okay, so from here we have what a function f, okay, with u and v, and then we have what a function of g, u and v. Okay, so in order to find what their Jacobian, or in simple terms what their determinant, okay, you just use the matrix approach, okay, to find what the determinant. So we have partial, so this is what partial derivative. Okay, so the partial derivative of f and g divided by what the partial derivative of u and v. Now take note of the notation. Okay, it's very important. I would just keep on repeating that. Okay, take note of the notation. Okay, so we have f of g and then u and what v. So we have f of u, f of v, and then what g of u, g of v. So from here you can notice that once taking the what determinant of this 2 by 2 matrix, we have what just f of u multiplying what g of v minus what f of what v multiplying what g of u. Okay, just cross multiplication. Okay, that is what Jacobian is all about, finding what the determinant of either a 2 by 2 matrix or what a 3 by 3 matrix. Okay, once you get this topic will be very easier for you. Right, let's proceed. Now look at how we do the words. This for what the 3 by 3 matrix. So we are done with what 2 by 2 matrix, and then this what form of a 3 by 3 matrix. So we have for f of u v w. Okay, same applies to g u v w, and what same applies to h u v w. So in this tutorial video, this will be a complete what tutorial video on what 2 by 2 and what 3 by 3 Jacobian what expressions, okay, or calculations. So once you understand this entire video, there is no need for you to go back to study the entire course, okay, or the entire subtopic. All you have to do is just solve more problems. Okay, so I might be leaving some problems in this video, okay, on this video, so that you get to practice your hands on them. Okay, right, so let's proceed. So this is what the 3 by 3. So we have what partial derivative of f g h, okay, and then what the same applies to what u v w. So this is how we write what the 3 by 3 determinant, okay, Jacobian. So the same applies to matrices, right? So let's proceed from there. Now again, as I stated earlier, Jacobian is all about taking note of what how you write the expression, okay, or how you write the determinant. So from here you have what a function of u and v, a function of g with u and v, such that u is a function of u with x and y, and then v is also a function of v with x and y. Now this is the most important or crucial part of what solving Jacobian. Once you get this part, it will be much easier. But once you don't get this part, it will be much more confusing to understand. Okay, so let's solve that portion over here. Now you could notice that we have partial derivative of what u over what partial derivative of what x. It means that when it comes to implicit differentiation of what Jacobian, it means that since you are taking u as a reference, when it comes to what finding the determinants, we don't introduce u in the determinants. Okay, so let me repeat that again. Since you are taking the Jacobian of what u with respect to x, when it comes to finding the Jacobian, you don't introduce u again. Now this is what I mean. So we have what partial derivative of u and what dx. Okay, so from here you know that we have what the partial derivative of f g, okay, divided by what the partial derivative of xv, okay, xv. You notice that we are taking f, these are f, okay, and these are what g. Now when we take the partial derivative with respect to or from referencing u, okay, from referencing u, it means that when doing the solution or when solving it, you just keep u in mind, but you'll be just differentiating with respect to what? Only v, okay? Only v. Let me repeat that. Once you are taking the partial derivative of what? U with respect to x, it could be u with respect to x, u with respect to y, u with respect to what? Z, okay? Depending on what? Either it's a 2 by 2 or 3 by 3, okay? Right, so once you make, once you write the expression as, or the formula as partial derivative of u with respect to x, when it comes to what? Writing the determinant, okay, we don't introduce u, okay, we use v, because with f and v, with f and g, we have what? U and v, okay, but since we are writing partial derivative with respect to u, you just introduce your v. So from here we have what? Partial derivative of f and g, but look at the denominator, we have what? Partial derivative of what? X and what? V, not x and u, okay? That is what I wanted you to know, right? And then when it comes to what? Writing the determinant, we have what? F of x, f of v, okay? And then g of x, g of v, okay? From here, so f of x, f of v, g of x, g of v. So the same applies to what? All these, okay? So we have partial derivative of v, okay, with the x. So from here, you wouldn't see any what? V. You only see what? U. So we have what? F, g, and what? Partial derivative of what? X, u. So from here we have what? F of x, f of u, g of x, g of u. Same applies to what? Taking with respect to y. So we have what? Partial derivative of u, but from here we have what? Only v, okay? Same applies to what? V with y. Partial derivative of v, but we have u over here. So take note of how we write these expressions, okay? Take note of how we write these the equation, because, or the how to go by solving it, because once you miss this, you get everything wrong, okay? You'll be marked down. So take note of how you write this. Again, once you are taking what? The partial derivative with respect to maybe u and v, once writing the determinant, you wouldn't introduce the what you are referencing, okay? So from here you reference what? U. So once you're writing the determinant, we write what? V, because f and g already have u and v in them because of how the expression is being written, okay? So with respect to u and v, but once what? Taking the partial derivative of u, you most definitely use v, just like here, okay, here and there. So let's take some examples so that you get to understand, okay? This was just the concept. Understanding the concept will help you understand how to solve the problem, okay? Now let's look at this question. So we have what? Consider what? This expression f, okay, equals u squared minus v equals what? 3x plus y, and then we have what? G equals what? U minus 2v squared equals what? X minus 2y, and then we are told to find what? Ux, uy, vx, vy. So ux is the same as partial derivative of u with respect to partial derivative of what? X. Same applies to all of these, okay? So I might solve 3 of these, and then I'll let you solve the final one so that we get to proceed to what? The 3 by 3 determinant, okay? Right, so let's see how we do this. So first things first. You notice that this has been written in this form, okay? So all you have to do is just write this form in respect to what their derivatives, okay? You just write this in respect to what their derivatives, so that once trying to solve it, it becomes simpler, okay? It becomes simpler for you to solve it, okay? So now let's look at how we do that. Okay, so let's start from f, okay? So you know that f is equal to what? U squared minus what? V equals what? 3x, okay, plus y. So now let's write this so that we could just put it in a standard form. So we simply put all the expressions in standard form. So we already know that for implicit differentiation, we always put the expression in standard form, okay? Equate everything to 0, okay? So that's what we'll be doing. So we have what? F of what? uv, okay? And that will give us what? U squared. So let me use this arrow, okay? So that you don't get confused. So we have what? U squared v. So let's bring this one to the left hand side. So we have what? Minus 3x minus y. Then you equate all of that to 0. And then let's do that for g. Okay, uv. Then we have what? For g, okay, we have what? U. And then we have what? Minus 2v squared. And then we have what? X and what? Minus 2y. So let's bring that to the left hand side. We have minus x plus what? 2y equals what? 0. Now, after being able to, equate these expressions to 0, Okay, the next thing is to what? Find their derivatives, okay, because we are taking what? Their derivatives, okay, that's per the formula, taking the derivative. So let me write the formula so that you get to understand. So we have what? U of x, okay, is the same as partial derivative of u with respect to what? The partial derivative of x. So this is taking the partial derivative of what? F and what? G, okay, and then you divide that by what? The partial derivative of what? Note again, we are taking respect to what? U, so we have what? Partial derivative of x and what? V, okay, and then you write this in their matrix form, okay, matrix determinant form. That's a 2 by 2, so we have what? F of x, okay, f of what? V, and then we have what? G of what? X, and then G of V. Note, you could write this in a form where you feel comfortable. So you could start from what? Maybe the partial derivative of V, comma x, so that this will be what? F of V, f of x, G of V, G of x, okay? Anyhow you feel comfortable, just use that so that you get to understand whatever you are doing, okay? So first, we have to find the partial derivative of f of x, f of v, g of x, g of v. So in order to save time, okay, so let me show you something. So in order to save time, okay, help you save time, instead of finding only the what? Partial derivative of f of x, f of v, g of x, and then g of v, find the partial derivative of all the what? Notations, okay? So this is what I mean. So start from here. You take the partial derivative of what? F of u. After that, take that for what? F of v, f of x, f of y, and then you continue from what? G of u, g of v, g of x, g of y, okay? That's what I mean. So let's start from here, okay? Let's start from here. After that, we come to the second one, so 1 and 2. So let's take what? F of what? U first, okay? So for f of u, when you differentiate this, you end up with what? 2u. Okay, let's move on to f of v. For f of v, when you differentiate this, you end up with what? -1. Let's look at f of x. Okay, so for f of x, you have what? Minus what? 3, and then what? F of y. So for f of y, you end up with what? -1, okay? -1. Let's do that for g, okay? For g of u end up with what? Differentiate this, that's partially differentiate this, end up with what? 1. Let's look at what? G of v. So when you take the g of v, that's partially differentiate g of v, you end up with what? -4v, okay? -4v. And let's look at what? G of x. So for g of x, you end up with what? -1. And then what? For g of y, you end up with what? +2, okay? So you see how simple this is. Once you take or you find a partial derivative of all of the what? Expression or notations, it will be much easier for you to solve, okay? So let's solve this problem, okay? Let's solve u of x. So we know that u of x is the same as what? F of what? X, f of what? V, and then we have what? G of x, g of what? V. Now, from here, I've already treated implicit differentiation with you. So once you go through the playlist one, calculus of several variables, you'll be able to understand, okay? And then I've already treated matrices, okay? So you could go to our playlist and find videos on matrices, okay? So that you get to understand what determinants and what 2 by 2 and 3 by 3 determinants, okay? Now let's proceed from here. So we know that f of x is what? Let's see, f of x is what? -3. F of v is what? -1. G of x is what? -1. And what? G of v is what? -4v, okay? Right, so from here, you could just find the determinant, okay? So let's find the determinant, multiplying across. So we have what? -3 so we have what? -3 times what? -4v, okay? And then you subtract that from what? -1 minus what? -1 again, so we have what? So from here we have what? 12v, okay? And then you have what? -1 times -1, that's +1. So this will be what? Our answer for this question. Now let's look at what? uy, okay? U of y, so we have u of y, which is equal to what? F of what? Y, and then f of v, and then we have what? G of y, and then what? G of v, okay? And then we have what? F of y. F of y is -1. F of v, which is also -1. G of y, which is +2, and then G of v, which is what? -4v, okay? So from here, you could just do the simple what? Determinant, okay? So we have what? -1 multiplying what? -4v. Then you subtract that from what? -1 multiplying what? +2, okay? So from here we have what? +4v. Then we have what? -2, okay? -2. So from here you could just have what? 4v plus what? 2 as your final answer, okay? Right, so let's proceed. It's very, very simple. Okay, so we have what? Vx, okay? Vx. So we have Vx. So Vx is the same principle, okay? So we have what? V of what? X, okay? V of x. And then what? Since we are taking reference from what? V, you just use u. And then we have what? G of x, okay? And then what? G of u, okay? Very, very simple. Simple and what? Straightforward. So let's take what? F of x. So f of x is what? -3. So we have what? -3. And then what? F of u is what? +2u, okay? We have what? G of x. G of x is what? -1. And then we have what? G of u is +1, okay? Right, so let's solve that. So we have what? -3 times 1, that's -3 times 1, okay? Minus what? 2u, okay? Multiplying what? -1, okay? So this is what? This -3 minus what? -2u, okay? -2u. So we end up with what? -3 plus what? +2u. This is very, very simple. So you could do same for what? Vy, okay? You could do same for Vy. So as for that, I will leave it to you so that you solve it. And then let me know whatever answer you get in the comment section, okay? Right, so let's proceed to what? 3 by 3. So this was just what? A 2 by 2, okay? It was just a 2 by 2. Okay, so this is what? A 3 by 3. So from here you can notice that we have what? U, V, W, okay? And then we have what? X, Y, Z, meaning that is what? A 3 by 3. So first, let's write this in the form of what? Proper standard form for implicit differentiation, okay? So we know that f of what? So now we have what? F of u, v, and what? W, okay? Which will give us what? U minus what? V plus w, okay? Minus x minus y, and what? Positive what? 2z equals what? 0. That's for f, okay? Let's look at g. For g, which is what? U, v, what? W, we have what? 2u, okay? So we have 2u plus what? V squared minus what? W, and let's look at what? The right hand side. So we have one minus 2x. From here we have -3y, -3y. This is 3. Let me write that. So we have what? -3y, and then we have what? Positive z, okay? Positive z equals 0. And then let's look at what? Q. Q, u, v, w. Okay, we have what? U squared plus what? 2v minus what? 3w. And then let's send these ones to the left hand side, okay? These ones. So we have what? Minus x squared minus y, and then what? Positive z squared, all equated to 0. Now let me show you how you rewrite what? The 3 by 3, okay? So for 3 by 3, let's say you have what? Finding what? WZ, okay? For WZ, since it's a 3 by 3, we just write it in the form of what? A 3 by 3 determinant, okay? So we have partial derivative of what? F, G, and what? Q, okay? Divided by what? The partial derivative of what? U, V, what? Z, okay? Look at the notation. Take note of the notation. So from a 2 by 2, you notice that the notation was a bit different from these ones, okay? this is a bit different, okay? This is how you write what for the 3 by 3, okay? Jacobian 3 by 3 determinant for what these what partial derivatives, okay? That's all implicit differentiation, okay? So now from here you can notice that, as I stated earlier, the same principle applies. Since we are using what w, you won't see w over here, okay? You won't see w over here. You only use what u, v, and what we are just implicitly differentiating respect to, okay? So we have what f of what u, f of v, and then f of what z, okay? Move on to g. So g of u, g of v, g of z, and then we have what q of u, q of v, and what q of what z, okay? Very simple, very simple. Now let's do same thing for here. So we have to take what the partial or differentiation for each and every one of these is variables, okay? Implicitly differentiating. So we have what, let's start from f of u, v, w, and then move on to x, y, z, and do that for g and q, okay? So let's do that. So we have f of what u, f of u is what? So f of u will give us what, 1. F of v will give us what, -1, okay? F of w will give us what, +1. F of what x will give us what, -1, okay? F of what y, okay? F of y will give us also what, -1, and then f of z, okay? F of z will give us what, +2, okay? Let's do same for g. So g of u, 2, g of v will give us what, 2v, okay? From here, 2v. So g of what, w will give us what, -1. G of x, okay, will give us what, -2, okay? G of y will give us what, -3, and then g of z, okay? G of z will just give us what, 0, okay? From here, we won't get anything from here, okay? This is what z, sorry, this is z, so we get what, 1, okay? Z, and then let's look at what q, okay? So q of u will give us what, 2u, q of what v, q of v will give us what, 2, okay? Q of w will give us what, -3, okay? And then we have what q of what x will give us what, -2x, okay? Q of y will give us what, -1, and then q of what z will give us what, 2z, okay? 2z, right? So you can notice that once you do this becomes very simple. All you have to do is just write out what the equation and then just insert what the respective what answers, okay, or respective partial differentials, okay, the answers you had for taking the partial differentiation by using what, implicit differentiation, okay, right? So we have what, f of u gave us what, 1. F of v gave us what, -1. F of w, we don't have f of w over here, so we have f of z gave us what, 2. F of g of u gave us what, 2. G of v gave us what, 2v, and what g of z gave us what, 1, and then we have what q of u gave us what, 2u, q of v gave us what, 2, and then what q of z gave us what, 2z, okay? So now we have to take what the partial what the determinant. Let's take the determinant. So let me rewrite that over here, okay? So this is what w what z, right? wz. So let's write that. So 1 minus 1, 2, and then we have what, 2v1, and then we have what, 2u, 2, and what, 2z. So in case you already know how to take the determinant, this will be much easier for you, okay? But let's do it together. After that, we'll just proceed from there. Now, okay, so let's proceed from here. So let's take the respective determinants. Okay, let's start from 1. Okay, so we have 1. Let's take the determinant from there. So note that this is what? Positive, negative, positive. Okay, so 1, we have what? So we take what? This one. So we have what? 2v1, and then we have 2 minus 2z. Okay, then negative what? Negative 1, negative 1. Then you put that in brackets. So we have what? This side cut off. So we have 2, 1, 2u minus 2z. So we have what? 2, 1, 2u minus what? 2z. Okay, and then we proceed to what? Positive 2. We take the determinant. So we have what? This side. So we take what? 2v, and then what? 2u, 2. Okay, 2u and what? 2. Now let's proceed from here. So we have what? 1, still 1 out. So we have 2v minus what? 2v. So we have what? 2v multiplying what? Negative 2z. Okay, minus what? 1 multiplying what? Positive 2. This one side, and then since this is negative, this will become what? Positive 1. Okay, that will become positive 1. So let's group that and let's proceed from there. So now we have what? 2 times minus 2z. So we have what? 2 times what? Minus 2z. Okay, minus what? 1 times what? 1 times 2u. Okay, you put that one into brackets, and then we are left with the last one. So we have what? Positive 2. Okay, positive 2 with what? 2 times 2, that's what? 2 times 2. Okay, minus what? 2u times 2v. So you have 2u times 2v. Note that I would have, written the exact answer straight ahead, okay? But I want you to understand the concept so that you can also solve the problem on your own, because during the exams you do it to yourself, okay? That's why I'm taking time. Even if it's 2 plus 2 times 2, I just write 2 times 2. I wouldn't write anything straight ahead, okay? So we have what? Let's start from here. So we have what? 1 is outside. So we have 2v by what? Minus 2z. Okay, you could just write that ahead. Okay, so we have what? Minus what? 4vz. Okay, 4vz. That's from here, and then we have what? Minus what? 2 over here. Put this in brackets, and then plus what? We have what? 1 out. So we have what? 2 times minus 2z. So we have what? Minus 4 what? Z, and then we have what? 1 times 2u, that's negative 2u. Negative 2u. Okay, that one is also in brackets, plus what? 2 out, and then we have 2 by 2, that's 4, minus what? 2u times 2v. This is v, right? Let me check. That's the last part. Okay, yes, that's 2v. So we have what? 4 what? uv. Okay, very simple. Now let's proceed from here. Now from here you know that we have what? When you multiply 1 throughout, we have what? Minus 4vz minus what? This was for what? 2, right? So 2, that's here, plus what? When you multiply 1 throughout, okay, you end up with what? So let's clear this one out. Okay, and let's use a negative sign. So we have what? Negative 4z. Okay, and then 1 by negative 2u, we have what? Negative 2u, and then we have what? Plus or 2 by this one will give us what? 8. That's 2 by 4. Then minus or 2 by negative 4, that's 8uv. Okay, so you could just go further to simplify. Okay, when you simplify this further, you end up with what? Minus 4vz. Okay, plus 6, and then you have what? Negative 4z minus what? 2u, and then what? You have what? Negative 8uv. Okay, you could notice that this is very simple. This is how you take the what? 3 by 3 determinant for what? Jacobian. Now you could go further to solve for what? The next question was to solve for let's say Vx. Okay, so you use the same approach to find for Vs. Okay, use the same approach to find for Vs. Very simple. And then in case you are told to find what let's say you are told to also find what Wz. Okay, Wz, you use the same approach. You just take note of how you write them out. Okay, Fu, Fv, F what, X. Okay, and then you move on to what, Gu, Gv, Gx, and then what, I have what, Qu, Qv, Qx. Okay, very simple. So I hope this video was helpful. In case it was, kindly take time to subscribe to the channel, turn on your post notification by clicking on the bell icon so that you don't miss out on future videos. Like the video, share, and in case you have any questions, just let me know in the comment section and then I'll reply to you as soon as possible. Have a lovely day. Bye bye.